Okay, we've strayed a little bit from the IB syllabus here, but I feel I'd be remiss if I did not give you Ampere's law. Okay, so Ampere's law basically says that if we take an integral in a loop of the magnetic field around a wire, okay, that's going to equal some constant times the current that's flowing in that wire. And this is kind of a cool thing, right? So when we talk about, say, a wire is like this and how the magnetic field circles the wire like this, right? That's what we're talking about is this magnetic field generated by a current. And so what's interesting also is that the constant in this case, the magnetic permeability of free space, is highly suspicious. It's 4 pi times 10 to the minus 7th, right? And you might ask yourself, how did a fundamental constant end up being 4 pi? And the answer is that it was close to 4 pi, so they made it 4 pi. And you'll see that that's a very convenient number, 4 pi, because then we actually don't even have to use pi. You'll see in a moment here. Okay. So anyway, there's our Ampere's law. Let's apply Ampere's law, right? Let's have a wire here with a current in it. And let's go in the direction, of course, that the magnetic field would go, so we don't have any troublesome minus signs, right? And if we add up all of that magnetic field, well, B dot dl, right, is just B times 2 pi r, right? The integral of the distance is 2 pi r. The magnetic field is constant at a particular distance from the wire, right? And then that equals mu naught I. Right, so now we can solve for the magnetic field, and of course, just divide by 2 pi r, right? And now we've got our formula, right? So this is the magnetic field at some distance from the wire. That's in Teslas, right? R is the distance from the wire in meters. That's the current in the wire in amperes, right? And then mu naught is mu naught, right? Okay. So it's a particular distance from a wire. If I've got a wire like this, right? If I'm some distance from that, the magnetic field is actually not an X, it's out of the page on this side, right? And we can figure out that the magnitude of that based on the current and the distance that we are from the wire, okay? So I think we'll do maybe some examples of this.